Well, let's do some examples. Analyze the graph of the equation in the kind of x squared is equal to negative 12y by finding the vertex, the focus, the directrix, the 2 points that form the latus rectum. So once I see x squared, I know that the parabola is either open up or open down. And since it's negative 12y, then I'm gonna select the one that's open down. Then since nothing is added to x or to y, the vertex is going to be at 0, 0. Now to find the focus, that's going to be x squared is negative 4ay, or in this case, that's x squared is negative 4 what times what is 12, well, that's times 3. So this means that a is equal to 3. So the focus up and down, that means it has a value for the y axis, and that's negative 3, and it's 0 for x. Well, the directrix is going to be on exactly the same distance, opposite direction, so the directrix is going to be at y value. So the y value is going to be equal to positive 3. So I'm looking at parabola having a directrix at positive 3 and focus at negative 3 and the vertex at 0. Now we're going to find the lotus rectum. And since the distance between the focus and the directrix is 6 units, I'm going to go 6 units both directions. And my points that form lotus rectum are going to be 6, negative 3, and negative 6, negative 3. So 6, negative 3, lotus rectum 1, and lotus rectum 2 is going to be negative 6, negative 3. Now I'm ready to grab the parabola. The parabola is going to go from the vertex both directions smoothly. Next example, equation of the parabola with focus at 0, 5. Find the equation of a parabola, focus at 0, 5, and directrix the line y is equal to negative 5. So what this tells me is that a is equal to 5. Since a is equal to 5 and the parabola has directrix at negative 5 and focus at 5, I'm assuming that this parabola is going to be open up. Since it's open up, the equation is going to look like x squared is equal to 4ay. Or the equation is x squared is 4 times a is 5. So the equation is x squared is 20y. Well, let's graph. Lotus rectum at directrix at negative 5. Focus at 5. I'm going to find the lotus rectum by counting twice 5 or 10 each direction. So 10 and negative 10. And I'm going to connect those points with the vertex. The points that I'm plotting for lotus rectum are going to be at 10, 5 and 10, negative 5. And of course the focus at 0, 5, and the directrix is the line y is equal to negative 5. Next question, find the equation of a parabola with vertex at the origin. Find the equation of a parabola with vertex at 0, 0, axis of symmetry, is the y-axis, well, this tell me that my parabola will have axis of symmetry in respect of y-axis. Well, that means it's going to be either parabola up and up or parabola up and down. It's going to depend on where my focus is. And it says also it contains the point 2,3. So contains the point 2,3. So it's right here. Well, to contain this point, this parabola is going to be this way. So such parabola is going to look like x squared is 4ay. Well, I don't know what a is. However, the point 2,3 to be from this parabola means if I plug in x to be 2 and y to be 3, I'm going to receive a correct statement. So I'm going to plug in x to be 2, which is 2 squared, is 4a, and y to be 3. So we end up having 4 is equal to 4 times 3a, and we can divide by 4 both sides of this equation and divide by 3 to figure that a is going to be 1/3. Well, then the equation is going to be x squared is 4/3 y. So that's going to be my equation. To graph, I'm going to be using the focus, and again the focus is going to have 0 for x and 1/3 for y, so somewhere right here. And then the directrix is going to be y is opposite of 1/3, so negative 1/3. So we have some directrix over negative 1/3. And then to locate the lotus rectums, and they wanted me to determine the focus and the directrix, I figured it out already. So the lotus rectum points are going to be 2/3 away from the 0. So that would be 2/3 on the level of 1/3. And the second point is going to be negative 2/3 on the level of 1/3. So here 2/3, and I can see that this distance here is the same, and this distance being the same, and I'm going to graph. My parabola passing through 0 and having directrix y is equal to negative 1/3, focus of 0, 1/3, and lotus rectum points at 2/3, 1/3, and negative 2/3, 1/3. Those 2 points. Analyze parabolas with vertex hk, not necessarily at the origin. If a parabola with vertex at the origin and x of symmetry along the coordinate axis is shifted horizontally h units and vertically k units, the rules found in either section regarding horizontal and vertical shift will apply. We'll fill in the table and then find the matching graphs. So a parabola of the kind h plus ak, so we have some value, so ignore h and k. A parabola of this kind is going to be looking like parabola with focus at a0, or when the parabola has value for x and 0 for y, so this kind. Well, h has been added to the x value, to the focus. So instead of the focus being at 8, it's at some a plus h. And the focus is also raised to some k units. So the focus is right here at some a plus h and k. So the focus is right here. The parabola goes the same direction. So this parabola is going to have the equation y minus k squared is equal to 4a x minus h. If h was added to negative a, so again if we ignore the h and k, or we are looking at something of the shape of the parabola with negative a at the focus. When we shift the parabola with h units for x and k units for y, we end up having some parabola being, so I don't know if h is greater than a or not, but we are having some parabola of the kind open towards the negative x-axis. And I incorrectly grab that parabola passing through 0. It's gonna be, it doesn't need to be through 0. And it also can be way deeper than the y-axis. Depends on how big h is. I'm gonna graph it smaller. So this equation is gonna be again y minus k squared, but then negative 4a x minus h. Well, now when the focus is at 0a, we are looking at the parabola that has a value for the y value, the focus that has a value for the y value. So situation like graph like this before. Well, now it has h has been added, k has been added to a, so we are having at some h a plus k, so let's say parabola of this kind. So this equation is going to be the x square equation. X minus h square is equal to 4a y minus k. And the last example, which is analogical to 0 and negative a, it's going to have the equation x minus h square is negative 4a y minus k, and it's going to be analogical to the one parabola that's up and down, or it's going to be some kind of parabola up and down. So to review, if I have a parabola with a vertex at hk and it's open towards positive x-axis, that's the kind of y square. So from y square is 4ax, this parabola is going to be y minus the y value squared is equal to 4a x minus h. Parabola that's open towards negative direction, and see how I'm not sure if this parabola is here or here. It just depends on how big h is. But such parabola is going to look like y square is equal to negative 4a x if it was if the vertex was at the origin. But in this case, that's going to be y minus k square is equal to negative 4a x minus h. And the last two cases would be parabola open up, so I'm gonna have x squared, so x minus h squared is 4a y minus k. And if the parabola is open downwards, I'm gonna have x minus h squared is negative 4a y minus k.